I thought I'd better put these these shredded holes in to hold the chuck on before I go and push them cups in. I've indicated off the inside here and then come on the outside of this boss just to double check. That's the best I can get it. I can't get any better than that. And that's the same on both surfaces. Okay, a good system with this touch DRO is how easy the bolt hole pattern is. Simply press the button. The chuck has a 95mm PCD. So half of that, which they want the radius, which is 47.5mm. The number of holes is 4. Start angle of 0. End angle of 270 degrees. And then we can go, that gives you coordinates here. So you can either just press on that one, that'll tell you where to go to. We can go preview workspace. I don't know whether you can pick up on the camera, you've got a dot here, 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 and here. So if I go auto select nearest point, it's telling me if I want to, I can go straight, move the y-axis, or I can just go to any point, whichever axis I decide to move first. As soon as I start going over, as it gets closer, it'll pick it up, and then it'll tell you how far to go. So if I want to go over to this one over here, and it's telling me to go this top one first, which is in the y-axis. So if I decide to go to this one on the left here, if you watch the numbers up here, it'll get closer, and then it'll jump. There we go. And that picks up my first hole. We're right to go. So it's a really good system, simple, easy to use, and it didn't take very long at all to learn that. It was very self-explanatory. I really like this touch DRO. And just out of curiosity, I have to go back to the center and get my cap off. Pick up that hole again. I'm going to plot this out and just do a visual check. It looks pretty darn good if you ask me. Yep. So that's a great thing about that touch DRO system. It's so simple to use. I really like it. I'm going to put the same system on my lathe, I reckon. Okay, I'll go through and spot them all with a center drill, then come back, because these have got to be 10 by 1.5, and I'll drill an 8.5mm hole. Okay, I'll go and tap the rest of these and bring this back. Righto, here's a test. It's a heavy bloody chuck, I know that. Pretty confident that these will fit. Three out of 4. They all fit. That is bloody awesome. Still need to deburr the back of these holes, but that fits absolutely beautiful. Feels even all the way around too, which is good. Okay, I've got to push these bearing cups in now. So, got the seals. And got scun like a bastard on them, I tell you. They didn't have them in stock, so I said, "Oh, we'll get some." They said, "We'll get some in for you." I said, "No worries." And they got them in. Cost me $6 each for the seals, and the bastards threw on $15 freight. So no doubt I wouldn't have been the only order from that shop. They would have ordered other stuff, but so I said, "I'm going to be the last time you actually get me. I'll go somewhere else and buy me shit." Thieving pricks. The amount of money I've spent there, and they don't miss you, I tell you. Okay, I'm going to go and clean these bores out now. Give them a good clean, take it over the press and press them cups in. Shade up this little one too, just to get down in the centre. She's home. That was a nice fit. She's home. So this is absolutely finished now, this part of it, and now I can get on with making the bloody Morse taper. Okay, the next part we've got to make is this arbor Morse taper 3. This is to take the bearings. Oil still runs here. So piece of shaft here, I believe it's 4140. So That should work out okay. I've got about 150 thou to come off this. So first dimension I'm shooting for is 36mm. I'm actually thinking I might lure this at 37 when I get the Morse taper on and held in the headstock with the Morse taper. But I'll turn the last millimetre off. That'll mean it's concentric with the taper then. I'll shoot for 37. We got 37. It's good. Okay, there's going to be a tang on the end of this, so I'm going to take this down to 18mm long, 18mm in diameter for the plan, say 23mm long. Got a stop set up down here, so should be pretty good to go. It's going to be the Morse taper portion, and take it down to 30mm. $30mm. Okay, I'm going to show you the way I set my compound to do the Morse Taper 3. I learnt this from Nigel at Go Create Hobby Machine Shop when I made the floating tailstock reamer. So what I do is I've got a 1, 2, 3 block. And I set it so there is, this is on 0 at 2 inches. So when I traverse the carriage back 2 inches, get to the 0. This indicator up here is set on the compound, which is on an angle. This has to read or move 1.28 millimeters. I know it's a mix of imperial and metric, but that's just the way it is. I find I can get it more accurate using a metric indicator than I can an imperial one. It's a little bit dark over here now. I just turned the light off over the lathe. So I've got the other dial indicator on the ways here, set at 2 inches. So this one here should do 1 full revolution and come back to 0.28. That's 1 mil. 0.2. The needle's just starting to move down here on this indicator. Jiggle it up to 0. We're a half division over. So I'll do it again, double check it. Make sure it's just not me. So just using the 1, 2, 3 block again to set this other indicator. That's reading 0, 1.1, 0.2, bring it up to 0. So we're at 0.29, so it's got to go back a fraction. Zero. Bring this one up to 0 on this one. There. Oh, 0.27. So it's just a matter of going backwards and forwards until you get it right. Pretty much what happens. Okay, I'll bring this around. You just can have a look at that indicator. That's 0.28. So I'm quite confident that is set correctly there. Go and check out Nigel's video and you'll see making this floating tailstock holder for when you're using reamers and that. Yeah, he shows it in his video, so and he explains it a lot better than I could ever do anyway. So go and check his video, Nigel's video out, and it works really well. I hope the finish turns out alright. That's all I hope. Don't like that finish much, eh? Righty, I was getting an absolute crap finish, so I've actually swapped over to the fast pulley, which I don't normally ever run the lathe on. Just, always run on the slow pulley. Anyway, it's running full noise now. So here we go here. Well, I've got that taper down a fair way now. This is a mile too long still, but I did leave extra on this end just in case I did take too much. I've still got a bit of room to play with. We'll see what sort of contact they got here. Pretty too much there, but anyway, here's what it is. So I've got an M5 to an M3 adapter. We're getting really good contact here. So it needs a very fine adjustment. The arse of the compound wants to go towards the back of the lathe. I've got some blue on the inside of this taper. And you can see from there to there, which that adds up with the length of this. I'm happy with that. Really happy. I didn't slide it on there very hard and it's stuck. So if I just give that a push, it's definitely sticking. So that was good. And I know this is too long here, that's fine. That's no dramas. I've got plenty I can play with here. On this end can be shortened up, no problem at all. So just put the radius in that corner. Chamfer this edge. Now I've got to work out how far I've got to come back and how much I've got to remove off this end here. Okay. Touch the bloody centre then too. This is at 18mm now, or should be. $18.04, close enough. That's got to have 2 flats put on there, a tang, and then I'll do that next actually, and then I've just got to chamfer this edge. Put it in the mill, put the tang on it, then I can put it in the sleeve, in the headstock, and do the features on this end.